Okay, so one other thing I want to point out about this example that we just looked at is we did find the two angles at which these two curves intersect. So if you remember how we did this, we set uh, 3 sine theta equals 1 plus sine theta, and then we got 2 sine theta equals 1, sine theta equals a half, and then we got theta equals pi over 6 and 5 pi over 6. Okay, but some astute observer would point out that, hey, just looking at these curves, that gives us these two blue points of intersection. What about this point? What about the pole? You're correct that, in fact, the pole is another point of intersection. But what's going on at the pole is uh, it's not happening at the same angle. Okay, so what do I mean by that? Okay, so we know r equals 0 at the pole. So for the curve r equals 3 sine theta, that occurs when 3 sine theta is 0. So that happens when theta equals 0 or, say, pi over 2. Alternatively, on the yellow curve, the 1 plus sine theta, if we set this equal to r equals 0, so 1 plus sine theta, then sine theta is equal to -1, which then means that theta is equal to 3 pi over 2. Okay, so even though r equals, so there is in fact an intersection point. So there is in fact an intersection point. Sorry, I had to quickly double check my trig. There is an intersection point, but they're not occurring at the same angles. That's not right. This one isn't right. This is pi. Okay, so let's look at our old friend, uh, the four-leafed rose. Okay, so in this example, we want to find all intersection points, find the points of intersection. For the curves, r equals cosine 2 theta, and r equals 1/2. Okay, so r equals cosine 2 theta. Remember, it looks like this. Somehow I'm not getting better at drawing those. And then r equals 1/2 is going to look something like this. Okay, so that's a circle of radius 1/2 centered at the origin. Okay, so just looking at this, we should be able to eyeball this. We should say that there's 1, 2, 3, 4, 5, 6, 7, 8 points of intersection. So let's find those 8 points of intersection. Okay, so set the r values equal to each other. So 1/2 has to be equal to cosine 2 theta. Okay, one thing we know, there's actually infinitely many points of intersection, but let's go on the interval from 0 to 2 pi. Okay, so cosine 2 theta has to be equal to 1/2. So what do we know about 2 theta then? 2 theta has to be pi over 3, or 5 pi over 3, or 7 pi over 3, or and 4 should be 11 pi over 3, so on and so forth. Divide everything by 2. So theta equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, there are a lot more, infinitely many more in fact, but these are the 4 that are on the interval from 0 to 2 pi. But that only covers half of the angles. Okay, so we get pi over 6, which should be here. Let's mark these in green. Okay, so that should be pi over 6 should be about there. 5 pi over 6 really should be that one. I really did a bad job drawing this. 7 pi over 6 should be that one, and 11 pi over 6 should be that one. So in fact, we're missing precisely half of the angles of intersection. Why is this? Okay, so if you remember when we talked about polar points, we can have r be negative. In fact, that's what's happening, is r could be negative. So that curve r equals 1/2, the curve r equals 1/2 is exactly the same as r equals negative 1/2. So let's figure out when the curve r equals negative 1/2 intersects cosine 2 theta. So negative 1/2 is equal to cosine 2 theta. That means that 2 theta should be equal to then 2 pi over 3 and 4 pi over 3, and then I think 8 pi over 3, 8 pi over 3, and 10 pi over 3, 10 pi over 3. There we go. Okay, and a lot more, but those, when we divide by 2 to get theta, are going to be pi over 6. No, 2 pi over 6 is pi over 3. There we go. That's better. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, and those should correspond to the other blue points. Okay, so all this is to say, if you're trying to find intersection points on polar curves, it can be a little tricky because maybe they don't intersect at the exact same angle. And there's also multiple ways of writing the same curve. Okay, so this can cause some issues when you're finding area between curves in polar form. So take a deep breath, make sure your angles are correct. Make sure your angles are going from the right part to the right part. Okay, and they should be in a continuous interval. Okay, so thank you for watching. We've got one more application.